Hello everyone, welcome to Spec eLearn, the online learning channel dedicated to chemical engineers. Today, we are going to discuss the course on types and classification of pumps. Pumps are of different types. Each type of pump is developed for a specific application. Nature of application, service operating conditions, safety and environmental needs dictate what type of pump is required for a given situation. Though all the pumps shown are used for liquid transport, they differ in their operating principle, construction features, and speed at which they need to operate to deliver required performance. So how are they classified and grouped? Let us move on to find out. Please subscribe now before you forget. Subscribing helps you to get message or notification when a new video is published so that you do not miss out on any new video. Watch the video till the end to get all the knowledgeable information at one place. The topic covered in this course are the type of pumps and their classification based on service criticality. Classification of pumps. Pumps may be broadly classified according to the principle by which energy is added to the fluid. Under this principle, pumps may be divided into two major categories: dynamic pumps and positive displacement pumps. This chart shows the broad classification of pumps: positive displacement pumps and dynamic pumps. Positive displacement pumps are further subdivided into reciprocating pumps and rotary pumps. Under dynamic pumps, we have centrifugal pumps, axial flow pumps, and special effect pumps. So, what is dynamic pump? Dynamic pump is one in which energy is continuously added to increase the fluid velocities within the machine to values greater than those occurring at the discharge, so that subsequent velocity reduction within the pump produces a pressure increase. What is positive displacement pump? Positive displacement pump is one in which energy is periodically added by application of force to one or more of movable boundaries of any desired number of enclosed fluid containing volumes, resulting in a direct increase in pressure up to the value required to move the fluid through valves and ports into the discharge line. Note the difference in the terms used here. The energy is periodically added as opposed to continuous addition of energy in dynamic pumps. Dynamic pumps. Dynamic pumps have several divisions of pumps that differ in their design and performance. Dynamic pumps are further divided into centrifugal pumps, axial flow pumps, special effect pumps. Of the three subcategories of dynamic pumps, centrifugal pump occupies the position of the most widely used family of pumps in the process and other allied industries. Centrifugal pumps are subdivided into a radial flow, mixed flow and peripheral flow pumps. Under the radial flow, we have single stage and multi-stage pumps. Under the mixed flow, we have single stage as well as multi-stage pumps. The most widely used pump under the centrifugal pump category is a radial flow pump. For chemical and process engineers, the knowledge of the radial pump is very important. In radial flow pumps, the fluid handled exits the pump radially. This means the fluid is pumped perpendicular to the shaft. Shown in this sketch is a radial type centrifugal pump driven by an electric motor. As illustrated in this figure, the radial flow pump accelerates liquid through the center of the impeller and out along the impeller blades at right angles, that is radially, to the pump shaft. Pressure is developed wholly by centrifugal force. Mixed flow pump. Mixed flow pump pushes a liquid out away from the pump shaft at an angle greater than 90 degrees. The term mixed flow describes a direction that is halfway between axial, that is along the axis, and radial, perpendicular to the shaft axis. Pressure is developed partly by centrifugal force and partly by lifting action of the impeller, as against 100% centrifugal force in the radial pump. Illustrated in this figure is impeller shape and the flow direction in a mixed flow centrifugal pump. Radial flow centrifugal pumps may be further classified as open impeller type and closed impeller type. Both these types are widely used in the industries. An open impeller has vanes that are open on sides without any protective shrouds. A closed impeller has vanes that are closed on both sides with shroud. This figure illustrates the two types of impeller. The open impeller, which has no shroud or a cover plate, and a closed impeller which has shrouds on both sides. Between these two is the semi-open impeller which has only one shroud, that is on one side. closed impeller, best used for clean liquids, as the vanes totally enclose the liquid for best performance. Open and semi-open impellers, less likely to clog than the closed designs, making them better suited for more viscous media and slurries, that is, liquids containing solids. Special effects pumps. Special effect pumps, which is a part of the dynamic pump family, include gas sleeve pumps, electromagnetic pumps. Gas sleeve pumps, also known as airlift pumps, are used to lift liquids laden with solids. Pressurized gas is injected below the liquid level into a pipe which is immersed vertically into the liquid. You need a compressor for this pump. The gas lifts the liquid and forces it into the discharge pipe. Not very commonly used in the process industries. Now let us move on to the next large category of pumps, positive displacement pumps. Why is it called positive displacement? A positive displacement pump causes a fluid to move by trapping a fixed amount of it and then forcing the trapped volume into a discharge pipe. With every pumping action, a fixed constant volume of liquid is pushed into the discharge pipe. Positive displacement pumps are further divided into reciprocating pumps and rotary pumps. The chart shown here shows the different type of pumps under the positive displacement category. The two main types are reciprocating and rotary. Under reciprocating, you have piston pumps or plunger pumps and diaphragm pumps. Rotary pumps are divided into gear pumps, sliding vane pumps, screw pumps and liquid ring pumps. Let us now understand the main type of pumps under the two categories, reciprocating pumps and rotary pumps. Reciprocating pump has an expanding cavity on the suction side and a decreasing cavity on the discharge side. This case shows a simple schematic diagram of a piston pump with increasing and decreasing cavity during the suction and discharge stroke respectively. The liquid flows to the pump as a cavity on the suction side expands, and the liquid flows out of the discharge as the cavity collapses by the action of a forward and backward moving piston or plunger. Here you can see the types and construction features of reciprocating pump. With respect to the position, the pump types are vertical and horizontal. With respect to the purpose or function, they are called metering or power pumps. With respect to the plunger acting, you call them a single acting or double acting type. With respect to the number of plungers in one casing, you call them a single, a duplex, triplex, or multiplex pumps. Illustrated in this figure is a triplex pump. 3 plungers are fixed in a single casing. You can also see how the rotary motion of an electric motor is converted into a reciprocating motion for the pump shaft. Shown in this sketch is a diaphragm pump. A diaphragm pump is a positive displacement pump that uses a combination of the reciprocating action of a rubber, thermoplastic, Teflon, or metal diaphragm and suitable valves on either side of the diaphragm, check valve or ball valve, to pump a fluid. Next, widely used type of pump under the positive displacement category is rotary pumps. Positive displacement rotary pumps are pumps that move fluid using the principle of rotation. Rotary pumps can be grouped into 3 main types: gear pumps, sliding vane pumps, and screw pumps. Illustrated in this figure is a gear pump. The pump has 2 gears rotating in the opposite direction, driven by 2 different shafts, one by the motor and the other the idler. The vacuum created by the rotation of the pump captures and draws in the liquid. Counterclockwise rotation of the drive gear creates a vacuum that draws a liquid. Shown in this figure is a sliding vane pump, another positive displacement or rotary pump. As opposed to gears meshing together, the sliding vane pumps operate through use of a number of vanes that slide into or out of the slots in the pump rotor when the pump is rotating. As you can see, the slots in the rotor allows the vanes to slide in and out as the rotor revolves eccentrically in the casing. This is akin to a piston and cylinder arrangement. As the pump rotates, a centrifugal force throws the vanes out of the slots. Push rods operating between the opposing vanes causes the vanes to move. As the rotor continues to rotate, the vanes are forced back by the inner bore of the casing into the slot as the cylinder bore decreases. The next widely used type of pump under the positive displacement rotary type is screw pump. These find applications in several industries, in refineries and petrochemicals, particularly for viscous applications. Screw pumps are more complicated type, featuring 2 or 3 screws with opposing thread. There is one screw turns clockwise, the other counterclockwise. The screws are mounted on shafts that run parallel to each other. The shafts also have gears on them that mesh with each other in order to turn the shafts together and keep everything in place. The turning of the screws and consequently the shafts to which they are mounted draws the fluid through the pump. As shown, in the sketch is a typical pump with male rotor having 2 lobes and female rotor having 3 lobes. Another important type of rotary pump used in the industries, particularly refineries and petrochemical and process plant, is liquid ring pump. One of the most widely used methods used for pulling vacuum is by use of liquid ring vacuum pump. Liquid ring pumps are pumps in which a liquid ring is formed from the surface liquid serves to transmit the energy required for compression of gases and vapors. A liquid ring pump has an impeller with blades attached to the center hub, located in a cylindrical body but offset from the center, that is eccentrically mounted. When the pump starts, the impeller swings the liquid sealant by centrifugal force to the outside walls of the body, forming a ring of liquid at the outside walls of the body. Because the impeller is offset from the body, some of the blades are immersed in liquid and some are almost out of the liquid. And this forms a cell. These cells act as chambers for the air and gas to enter and pushed by the liquid ring to the port at the outlet. So far we have discussed about 3 main types of pump categories: centrifugal, reciprocating and rotary pumps. Given that a liquid can be handled by any of the 3 basic types and given conditions within the coverage areas of all the 3, the most economic order of consideration for a given set of conditions would generally be centrifugal, rotary and reciprocating in that order. In many cases, however, either the liquid may not be suitable for all the 3 or other considerations such as self-priming or air handling capabilities, abrasion resistance, control requirements or variation in flow may preclude the use of certain pumps and limit the freedom of choice. Types of pumps. Classification by standards. Standards relate to the design and manufacturing of pumps. Pump standards are provided by 2 institutes: American National Standard Institute ANSI, American Petroleum Institute API. According to the standards by which the pumps are designed and manufactured, they are sometimes called ANSI pumps or API pumps. ANSI standards. Pumps meeting the ANSI standards often are chosen for less demanding chemical and utility services. ANSI standards refer to the dimensional standards. API standards. API standards focuses on developing petroleum and petrochemical equipment and operating standards. The most important API standard when it comes to pump design and manufacturing is API 610 standards. API 610 standards cover centrifugal, rotary, positive displacement pumps used in petroleum, gas and petrochemical industries. API 610 standards refers to pump's construction, design, and ability to handle high temperatures and pressures. APA 610 standard is most stringent and usually is considered the minimum specifications for pumps that handle hazardous, flammable, toxic, and explosive liquids. APA 610 standard is most stringent because any reliability issue or even a small incident in the pump could result in a disaster. The differences between ANSI and APA pumps can be summed up as below. The main variable is the service, that is, the liquid, the plant, the speed, and the desired reliability for the temperature and pressures under consideration. The other mechanical related difference is a pump mounting features. Shown here is an ANSI pump. Look at the pump mounting feet and compare with the APA pump, which is shown next. You can notice the differences between APA pump and the ANSI pump. Take also note of the end flange connection in the APA pump in this figure. They are designed for high pressure and temperature for enhanced reliability. The preferred applications for APA pumps are listed here. APA pumps are preferred in the following situations. For a differential pressure of more than 20 bars, APA 610 usually is specified, even for some critical water and utility services. For extreme temperature services, where the pumped liquid temperature exceeds 140 degrees centigrade, even in some critical water services such as boiler feed water pumps or low temperature applications. In some cases, 5 water and critical cooling water pumps are specified to comply with the APA 610 standard to achieve high reliability. The cost alone should not be the driving factor in selection of the pump. The safety of the operating personnel working in the plant is the most important consideration apart from other environmental considerations. Before we end the discussion on the type of pumps, I would like you to have a look at the comparison of different types of pumps on one parameter called specific speed. Specific speed is usually and specifically applied for centrifugal pumps. In a more generalized way, they can be used to compare different types of pumps. This comparison is shown in this figure. One definition of specific speed is the speed at which the pump will operate, delivering unit flow under unit head. In other words, it can be termed as the ratio of flow to the head. In the above figure, the specific speed is given in English units. Positive displacement pumps have low specific speed, ranging from 27 to 275. Centrifugal pumps have the specific speed varying from 500 to 20,000. Reciprocating pumps have the lowest specific speed. That means the lowest flow to head ratio. Please subscribe to our channel and get updates on the upcoming courses by pressing the subscribe button. It will motivate us to produce free, knowledge-rich video content for you. With this, we have come to the end of the presentation. Hope this presentation with narration and animation was useful. Please give your comments, if any, about this course after you have finished viewing the video. Share with your friends and colleagues to reach out to large number of career-oriented professionals and students who are desirous of developing job-oriented skills and enhancing the knowledge base. Thank you for watching.